All right, everyone. Today we are going to cover in this video lesson 2-2, proving lines parallel. So proving that two lines that you see are parallel. So it's not enough in geometry to just say, oh, those lines look like they're parallel. I'm going to say they're parallel. In geometry, we say, well, prove that they are parallel. So we're going to look at some converses, some examples, and go through this. So I tried to save us from writing too much today by using these fill in the blank notes. Those of you at home without copies of this can simply copy down just the examples that I do. You don't need to write all of these printed words. As long as you have it to look at and refer to, that's fine. You can just write down the examples and follow along so that you can do the practice today that comes after the video. So this is a table here of, these are all, you should recognize all of these as the types of angles that we have gone over in our last video. And now we have added on this word, which is converse. And we're going to look at writing these statements as if-then statements. So you may remember that from last week where we did conditional statements and we said, you know, if you live in Seminole, then you live in Florida. So those were conditional statements. Now we're seeing how those actually apply to the geometry concepts that we're talking about. So this first one, we're taking corresponding angles, which we know what that looks like. And now we're saying if two lines are cut by a transversal, so a line that cuts two other lines, so that corresponding angles are congruent, then the lines are parallel. So previously we were saying if two lines are parallel, then the corresponding angles are congruent. That's what we talked about last class. Now we're looking at the converse, so kind of going backwards. So we're saying, well, if I've got these two lines and the corresponding angles are congruent, then those lines must be parallel. So that is the corresponding angles converse. So we can look at examples of those. So we would say, let's say we have these two congruent angles. Let's look at some corresponding, 1 and 5. So 1 and 5 are corresponding angles. So we could say, if the measure of angle 1, and of course I don't have to write all that out, I'm using my symbol. So if the measure of angle 1 is congruent to the measure of angle 5, so again I picked two corresponding angles where they're both in the same position, then that means, so if these two are equal, then that must mean that L is parallel to M. And here's how I write that. L parallel to M. Okay, so a lot of symbols, but it helps us so we don't have to write so much. In geometry, we're just using symbols to say all of this. So let's look at another one. Alternate interior angles converse. So now we're saying, okay, if alternate interior angles are congruent, then the lines are parallel. So it's kind of going to be the same thing over and over with each type of angle relationship that we looked at in our last video. So we're saying now, okay, well, let's pick out a pair of alternate interior angles. So let's see what we remember. Alternate interior, so opposite side, but inside the parallel lines. So interior, all of these angles are going to be interior. So I can pick, say, 4 and 6. 4 and 6 are alternate interior. Also 3 and 5, I'll just pick 4 and 6 because why not? So I'm going to say if angle 4 is congruent to angle 6, then that must mean, so if these are equal, then that must mean that L and M are parallel. So I can prove it. I left off the M. You'll see it either way, so I just left off. There's no difference here. We're saying the measure of angle 1, angle 4, it's the same thing. So now we just did the alternate interior angles converse, and now we'll do the same thing with the alternate exterior angles converse. So now exterior, these outside angles. So if I pick some alternate exterior angles, let's say I pick 2 and 8. 2 and 8. So opposite sides, but they're on the outside of the parallel lines. So if I say if angle 2 is congruent to angle 8, then that must mean that line L is parallel to line M. So that's what we're saying. So it's kind of like, if I saw this picture, oh, those look like they're parallel. Well, how do I know if they really are parallel? Maybe this one has like a slight decline and eventually they'd run into each other. So if I wasn't sure, well, then I can say, oh, well, 2 and 8, they're congruent. So these lines are parallel. It's a way to prove that. So our last one here, I crossed out consecutive. Our textbook and most textbooks call it same side interior angles converse. So just cross out. You will see it as same side, which sounds a lot less confusing than consecutive, I think. So now we're talking about interior angles that are on the same side of the transversal. And let me just actually remind you that this line that cuts through is the transversal. So whatever line is forming all of the angles, that's our transversal. So I just want to point that out again. And then, so now same side interior angles, remember though, they are not congruent. So if we look at, say, let's say we look at 4 and 5 here, they are interior, so they're inside, and they're on the same side. So they're not equal, okay? They're not congruent. They are supplementary, meaning they form a line together. So if two lines are cut by a transversal, so that, let's cross that out again. So that same side interior angles are supplementary, then the lines are parallel. So we'll say if the measure of angle 4 plus the measure of angle 5 equals 180 degrees. If I add those two together and I get 180, then that must mean that L is parallel to M. Okay, so those are all of our converses for these special angle relationships. So now what we have to do is use all of these to determine which lines are parallel, and then we're going to use these to justify our answer. So how we know something is parallel, or how we know they're congruent, or such like that. And then we're going to look at 2-column proofs. So let's start here with angle 2 congruent. Angle 2 congruent to angle 4. So if we say that angle 2 and angle 4 are congruent, the question is, which lines then are we implying are parallel? So what are the two parallel lines that make 2 and 4 congruent? So you have to be careful here because I see two sets of parallel lines. I see A and B, but I also see C and D. So how do I know which ones I'm talking about? So you want to look at which lines are those two angles touching. So for example, let's say I thought my answer was A and B. Okay, well, 2 and 4, neither one of those are on line B. Okay, they're not on line B. They have nothing to do with line B. So they are not proving that A and B are parallel. They're proving that C and D are parallel. So angle 2 is on line C, angle 4 is on line D, and then they're being cut by this transversal A. And A is what is forming those angles on these two parallel lines. So we would say C is parallel to D. Okay, and I know that this, this can be a little bit confusing. It's a lot of angles that you're looking at. So you really just want to pause and take a moment and make sure you understand how I knew to choose C and D. Okay, so I chose C and D because 2 and 4 are on line C and D, and they're also on this transversal here. They're not on B, so I couldn't say A and B. Okay, so now the converse, now we're basically saying what kind of angles are these, and how do we know that they're congruent? So what converse? So converse here, I'm picking from these 4. So these 4 are my options. What type of angles are these? So if you look, and this is from yesterday's video, 2 and 4, they're both in, like, we would say, I say the top right, those are corresponding angles. So I'm going to say corresponding angles. Make it a little brighter. Okay. So let's look at another one. Angle 5 and angle 10. So which 2 parallel lines are those on? They are on this line and this line, so that's A and B. Okay, they're not on C and D. So we would say A is parallel to B. So as we go through these, it should start to make a little bit more sense. So you can see 5 and 10, they're on A and B, and they're being cut by this transversal C. So this just takes practice, and you're going to do some practice after this as well. So you'll want to be referring to these notes to kind of help you. So now the question is, well, what type of angles are 5 and 10? So I see that they're on opposite sides of the transversal. So it looks like it's going to be one of these alternate interior or alternate exterior. And then when I look, they are inside the parallel line. So they're inside A and B. So I'm going to call these alternate interior. I'm going to abbreviate here. They're alternate interior angles. Okay. All right. Let's look at C. And then maybe I'll have you try some of these. So C. Angle 6. We're saying 6 plus 10 gives me 180. So 6 plus 10 gives me 180. So I am wondering, what parallel lines are these on? Well, they are touching 2 lines. They are not touching this D line at all, so I know that it's going to be A and B. So they're both on A and B and touching this transversal C. So that's going to be A is parallel to B. So those are my 2 parallel lines. And then this makes it kind of easy when it's the converse. So there's only one option up here that's talking about them adding to 180 rather than being congruent. So this would be our same side. Same side interior angles. So that's 6 and 10. And you can tell, right? They're on the same side and they're interior. So let's see if you can actually try to fill out the rest of this table on your own. It's really good practice for you, a really good idea for you to try these on your own so you can start to kind of look at it and process it in your mind. So I'm going to say to pause and give these a try. Oh, and keep in mind, sorry, almost forgot to say that some of these angles might not have a relationship. So I will say that 2 of these are none, where there is actually no relationship between the 2. But go ahead and try these out. All right, so take a look at my answers here. Hopefully you had some similar ones. It's okay if you got some of them wrong, but the main thing is that you were looking and really trying to think about these angles and what type of relationship that they have so you can get comfortable with identifying these angles when you see them on parallel lines cut by a transversal. So let's see here. We had angle 1 and angle 14. So these are alternate exterior angles, so I just abbreviated here. And that means that A is parallel to B. So I think it kind of helps to maybe if you identify which line these two angles are not touching, then you can say, okay, well, that's not a part of the parallel line. So like for example, with A and B, 1 and 14, they're touching C. They're touching A and B, but they're not touching D at all. So they have nothing to do with D. I can almost just like totally ignore D and pretend it like it's not there. So if I kind of like ignore all of this stuff, then it can paint a clearer picture for you that you have A and B, and then they're being cut by the transversal C. And then the next one, so 14 and 15. I've got 14 and 15 here. So let's think about they're touching C and D, being cut by B, not touching A at all. Okay, so we're proving that C and D are parallel. And if you kind of rotate, maybe you can see it a little bit better, but so 14 and 15, they are same side interior angles. So they add to 180. Next one. So this was a kind of a trick one. Well, not a trick, but there's no relationship between these two. So that would have had to really make you think for a second. So 11 and 16. Now, when I say no relationship, yes, they are vertical angles. That's true. They're congruent, but that doesn't prove lines parallel. So it's only these converses that are going to prove two lines parallel. So vertical angles actually doesn't help me prove a parallel line because if you look, 11 and 16, well, they're touching B and D, right? But they're not touching C and they're not touching A. So I can't prove that any lines are parallel based off just these two angles. So they don't really help me with anything regarding proving lines parallel. So they're none. They are nothing. And then angle 4 and angle 15. Angle 4, angle 15. So they're both on A and B, and they're being cut by D, and they are alternate exterior angles. And then I have 10 and 12. So angle 10 and angle 12, they're both on C and D, and they're being cut by transversal B. So C is parallel to D, and they are corresponding angles. We have another none one. So 9 and 13. If you look at 9 and 13, yes, they form a linear pair. They do, but that's it. They're not same side interior angles. They cannot help me prove any two lines parallel. So they are none. I cannot prove parallel lines, just a linear pair. So it would be none. And again, you can kind of see 9 and 13. Okay, they touch line C and line B, but they don't touch A or D. So I can't prove any sort of parallel relationship. And then angle 2 and angle 7. 2 and 7. So I see that they're touching C and D, being cut by A, and they are alternate interior angles. So they're inside C and D. And then angle 6 and angle 11, they are nothing. So if you look at 6 and 11, they really have no relationship that I can see. So they would be none for that one. So on the back here, there's another problem that I'd like you to try on your own. See what you can figure out, just looking at, which lines are parallel, what transversal are they being cut by, and then what type of angles they are. So give this one a try, pause the video and see if you can figure any of these out, and then we'll go for the answers. All right, so hopefully you pause the video. Here are my answers. And you can check them here. So why don't you take a moment to check your answers, and if you got it wrong, just you can fix it, no big deal. See if you can get your mistake. So again, I'm looking, I want you to think of, when you're looking, look at which two lines these angles are touching and what transversal they are being cut by. That's a Q, not an A. All right, okay, let's take a look at some proofs. So what is a proof? What's a two-column proof? You're going to see them down here. So with a proof, we need to prove something. We need to prove that something is true. So in this case, we need to prove that these lines are parallel, and we'll be given some sort of information. So for you, doing a proof like this, you're always going to have a drop-down menu of options of what to fill in. Okay, so you're always going to have options. You're never going to have to come up with these reasons on the spot. So for today, of course, it's just knows it's not a drop down. We'll come up with the reasons. You might feel like these reasons are just like coming out of thin air, but you will have options to choose from, so you'll have an idea of what to put. So first of all, we always are given some sort of information. So we're always given a piece of a puzzle, okay? So if you ever do a Sudoku puzzle or a Ken puzzle, you're always given something, and then it's your job to figure out the rest based on the information you've been given. So in this one, I'm given the fact that angle 4 and angle 5 are supplementary. So they're telling me. So now, since angle 4 and angle 5 are supplementary, please prove to me that J and K are parallel. So here are my reasons. Here are my statements. So the first statement is that angle 4 and angle 5 are supplementary. Well, that was given information. So how do I know that? Okay, sorry, got cut off there. So I'm coming back. I just said that this information was given to me. So now my next statement is that the measure of angle 4 and the measure of angle 5 equal 180 degrees. Well, how do I know that? What's my reason for saying that? Well, I know that because I know the definition of supplementary angles. That is how I know that. So my reason for saying that angle 4 and angle 5 add up to 180 degrees is the definition of supplementary angles. All right. So now I come to the final conclusion that J is parallel to K. So what converse, so now if you're thinking back to the converses that we did, which one told me that when I am able to add these two angles and get 180, it told me that those lines were parallel. So if I look back over here, it was the same side interior angle converse. So I'm going to write the same side interior angle converse. Again, so this would be a drop down for you. Like it's, at this point, how are you just going to come up on your own that we're talking about the same side converse? You're going to have some options and you're going to see, okay, those are same side interior angles. We're going to use the converse. So this is just an example of what a completed proof will look like. So you are going to practice with this today, but you will have drop-down menus for these options. So it's just about knowing kind of like your vocabulary words and what those relationships are. So let's look at another one together. A little bit longer, so 2 extra steps. And this one says, given that angle 1 and angle 2 form a linear pair, angle 4 and angle 1 are supplementary, prove that A is parallel to B. So now we kind of have to, we have a little bit of a longer route here to get to the same idea. So we're still trying to prove that A is parallel to B, but these angles are, kind of, I have to just do this in a little bit more steps than I did in the last one, that's all. So angle 1 and angle 2 form a linear pair. Well, that was given to me. Okay, so in proofs, we always start with the given information. So that was given to me. Now, angle 1 and angle 2 are supplementary. So how did we know that? Same way up here. Well, I know the definition of a linear pair. Okay. Angle 1 and angle 4 are supplementary. How do I know that? That was also given to me. So that's nice and easy. That's given to me as well. Now, angle 2 is congruent to angle 4. How do I know that? So this one is going to be the congruent supplement. The congruent supplementary theorem. So that's basically a theorem saying that if you think about this, if angle 1 and angle 2 are supplementary and angle 1 and angle 4 are supplementary, then angle 2 and angle 4 must be congruent, since they're all going to add up to 180 degrees. So now, knowing that angle 2, so let's look at angle 2 and 4, knowing that angle 2 and 4 are congruent, what types of angles are those? Those are corresponding angles. So I can use the corresponding angles converse. And I have proven that A is parallel to B. And that is all for your notes today. So you're going to practice with some questions online. And you'll want to use these notes to kind of help you out a little bit, but the practice is going to be really important to really understanding this material. You're not going to really fully master this content until you try it for yourself. So make sure you are actually trying on the practice so that you can understand this material.